Welcome back, everyone, to the deep dive. We love to really dig into some fascinating research, and today we're diving into the world of large language models.
LLMs.
Yes, LLMs, those AI systems that seem to be popping up everywhere these days.
And specifically, we're going to be looking at how these LLMs adapt when they're interacting with other agents.
So, not just doing their own thing, but actually responding to others.
Exactly. It's about how they behave in dynamic interactive situations. And our source material for this deep dive is a research paper titled, "Can Large Language Models Adapt to Other Agents in Context?"
Catchy title.
It really gets to the heart of what this research is all about.
So, what makes this research stand out to you?
Well, you see, most research on LLMs focuses on, can they understand what other players are doing? But this goes a step further.
Oh, how so?
This research asks, can they use that understanding to make smart decisions?
So it's not just about comprehension, it's about using that knowledge in a strategic way.
Precisely. It's like the difference between knowing the rules of a game and actually being able to play it well.
Right. Makes sense. So how did the researchers actually go about testing this?
Well, they use some classic games that I'm sure many of our listeners are familiar with: rock, paper, scissors,
A classic.
the iterated battle of the sexes,
Okay. Get a little more complex.
and even the prisoner's dilemma.
Wow. So they really covered a range of strategic interactions.
They did. And to make things even more interesting, they added a twist.
Oh, a twist. I like where this is going.
They put the LLMs in a situation where they didn't have perfect information about the game or their opponent.
So they couldn't just rely on knowing the rules they had to deal with uncertainty?
Exactly. And the researchers have a fancy term for this. They call it a decentralized, partially observable Markov decision process.
Okay, that's a mouthful.
But you can think of it like playing a game in a fog of war.
Yeah.
Some things are happening, but you don't have the full picture.
So it's like making decisions in the real world where you never have all the facts.
Precisely.
And to make things even more interesting, the researchers focused on two different levels of what they call theory of mind.
Right. This is a key concept in understanding how agents interact.
Can you break that down for us a bit?
Absolutely. So the first level is literal theory of mind, which is the ability to predict what another agent will do.
Okay, so if you're playing chess with a friend and you're trying to figure out their next move, that's literal theory of mind.
Exactly. You're anticipating their actions.
So it's like being able to guess what someone's going to do, even if you don't know for sure.
And then we have the second level, which is where things get really interesting.
Okay, lay it on us.
It's called functional theory of mind.
And how's that different?
Well, it's not just about predicting what someone will do. It's also about using that prediction to make smart decisions and adapt your own behavior.
So it's not enough to just know what's coming. You have to be able to react to it in a way that benefits you.
Exactly. It's about making strategic choices based on your predictions.
So it's like you can predict your friend is going to order pizza, but can you use that knowledge to decide whether you want pizza or something else?
That's a great way to put it.
So what did the researchers find out about how LLMs perform on these two levels of theory of mind?
Well, this is where the research uncovers something quite surprising.
Oh, I love surprises.
They found that LLMs often display excellent literal theory of mind. They're really good at predicting what their opponent will do.
Okay, so they've got the prediction part down.
But when it comes to functional theory of mind, actually using those predictions to win the game,
Yeah.
they often fall short.
Hold on. So they can predict what's going to happen, but they don't know how to react in a way that benefits them.
That's essentially what the research found.
That's pretty unexpected. Do they give any specific examples of this in the paper?
Oh, absolutely. There are some really striking examples that illustrate this gap between literal and functional theory of mind.
Okay, I'm all ears. Let's hear it.
One example that really struck me was from the rock, paper, scissors experiment. Imagine playing against an opponent who always chooses rock. Seems like a pretty easy opponent to beat, right?
Yeah, you're just going to play paper every time.
Exactly. And a simple computer program would do just that. It quickly learns the pattern and exploits it.
So what happened when they put the LLMs up against this rock spammer?
Well, that's where it gets interesting. The researchers found that even large, sophisticated LLMs like LMA2 struggled to consistently beat this predictable opponent.
Wait, we're talking about AI systems that can write poetry and generate code, but they can't figure out how to beat a rock spammer in rock, paper, scissors.
That's a bit of a head-scratcher, isn't it?
There has to be a reason for this. What did the researchers find out?
They dug deep into why this might be the case, and one key factor they uncovered was the way these LLMs are trained.
Ah, so it's not just about the size or complexity of the model, it's about how they learn.
Exactly.
Mhm.
You see, LLMs learn by processing massive amounts of text data,
Right, they're like giant sponges soaking up all that information.
and this gives them incredible pattern recognition abilities, but it also instills certain biases.
Biases.
Yes, ways of thinking that are shaped by the data they've been exposed to.
So it's like they're picking up habits or assumptions from all that text they've digested.
And those habits might help them in some situations, but also hold them back in others.
Interesting. So how did the researchers investigate this?
They did something pretty clever.
Hmm.
They tested how these biases might influence performance by changing how actions in the games were represented.
Oh, like changing the words they use to describe the moves?
Precisely. Sometimes they used real-world terms, other times neutral symbols, just to see how those built-in biases might affect gameplay.
So by tweaking the language, they could see if the LLM's preconceived notions were getting in the way.
Exactly. And they found something quite significant.
What did they find?
This inductive bias, as they call it, was a double-edged sword.
How so?
Well, early on, those biases from real-world language actually helped the LLM perform well.
So it's like they were leveraging their knowledge of how those words are used in everyday life to make decisions in the game.
But here's the catch. As the game progressed, those same associations sometimes became a hindrance.
Ah, they'd get locked into patterns based on their initial understanding, even when those patterns were no longer the best strategy.
Like you learn a shortcut to work,
Uh-huh.
but then there's construction and you stubbornly stick to your usual route, even though it takes longer.
I've definitely done that. So basically, they're getting stuck in a rut because of their early assumptions.
Precisely. And that's a key takeaway from the research. We need to understand and potentially address these biases if we want LLMs to become truly adaptable in complex situations.
Makes sense. Now, you mentioned earlier that the research included some detailed results. Did any of those data points particularly stand out to you?
Absolutely. Let's take a look at a few specific examples from the research paper. We can see these patterns play out in the numbers.
Okay, fire away.
For example, Figure 15 shows the results of LMA3, a very powerful LLM playing rock, paper, scissors against an opponent using the classic tit-for-tat strategy.
Tit for tat. That's where you mirror your opponent's previous move.
Yeah, exactly. So if your opponent played rock, you play rock on your next turn.
Simple, but effective. So how did LMA3 do against this strategy?
Well, that's where it gets interesting. It didn't do as well as you might expect. The graph shows its performance measured in terms of something called regret, fluctuated quite a bit.
Regret. What exactly does that mean in this context?
Regret essentially measures how much better the LLM could have done if it had made different decisions. So higher regret means it missed opportunities to win.
So even against a fairly simple strategy like tit for tat, the LLM couldn't consistently come out on top.
Exactly. And if we jump to Figure 21, which looks at the same scenario, but for the game of iterated prisoner's dilemma, we see a similar trend. There are moments where it seems like the LLM is catching on, but overall, its performance isn't optimal.
So it's not quite mastering the art of strategic decision-making, even when the rules are fairly straightforward.
And that's what makes this research so fascinating. It's challenging our assumptions about what these powerful AI systems are truly capable of.
It's like they're so focused on predicting the future that they're missing out on opportunities to shape it to their advantage.
A valuable lesson for all of us, perhaps.
Yes.
And it highlights this gap between what we think LLMs should be able to do and what they can actually do in practice.
So where do we go from here? What are the next steps in this field of research?
Well, the researchers definitely don't leave us hanging. They offer some really thought-provoking avenues for future exploration.
Like what?
One key takeaway is that simply making LLMs bigger isn't the answer.
So we can't just throw more data at the problem and hope for the best.
Exactly. We can't just expect them to magically develop this functional theory of mind just by increasing their size.
So it's not just about size, it's about finding ways to make them smarter in a very specific way.
Right. And one idea is to focus on helping LLMs develop a deeper understanding of the context in which they're operating.
So not just recognizing patterns, but understanding the why behind those patterns.
Exactly. They need to grasp the underlying cause and affect the goals and intentions of the other agents they're interacting with.
Because right now it seems like they're kind of just reacting blindly based on those surface level patterns.
It's like the difference between knowing all the grammar rules of a language
Mhm.
and actually being able to write a compelling story.
Ah, so you need more than just the technical knowledge. You need an understanding of how to use that knowledge effectively.
Precisely. And to achieve that, we might need to incorporate insights from other fields, like game theory, decision theory, even cognitive psychology.
It's like we need to give them a crash course in human behavior.
In a way, yes.
Yeah.
We need to teach them not just what to do, but why to do it.
So this is going to require a very multidisciplinary approach, bringing together experts from different fields.
Absolutely. And another crucial point the researchers raise is the need for more robust evaluation methods.
So the way we're currently testing these systems might not be giving us the full picture.
Right, the standard tests we use for assessing human theory of mind might not be sufficient when it comes to LLMs.
Because they might be passing those tests but still struggling in real-world interactive situations.
Exactly. So we need a new playbook,
Yeah.
a new set of tools for measuring AI intelligence that's specifically tailored to this functional theory of mind challenge.
It's like we need to raise the bar and create tests that really challenge their ability to use their knowledge strategically.
And those tests should go beyond just measuring prediction accuracy.
Yeah, we need to see how well they can actually translate those predictions into successful actions in complex environments.
It's about performance, not just potential.
Well, this has been a truly fascinating deep dive. We've covered a lot of ground, from simple games like rock, paper, scissors to these really profound questions about the future of AI.
It's been a pleasure exploring this with you.
What are your final takeaways from this research? What's the big picture here?
For me, it really highlights the fact that we're still in the early stages of understanding the true capabilities and limitations of LLMs.
We're still figuring them out.
They can do amazing things, but they're also capable of surprising us in ways we don't always anticipate.
It's a humbling reminder that we don't have all the answers yet.
And that's what makes this research so important. It's pushing us to think deeply about not just what AI can do, but what we want it to do and how we can ensure its development aligns with our values and goals.
It's a call to action for all of us to engage in this conversation and help shape the future of AI in a responsible and beneficial way.
I couldn't agree more.
And on that note, to all our listeners, we hope you enjoyed this deep dive into the world of LLMs and functional theory of mind. It's a rapidly evolving field, and we're excited to see what the future holds. Until next time, keep exploring, keep questioning, and keep diving deep.